My dear students, I welcome all of you to the class. In this class, we will discuss about different types of functions and it is based on the characteristics of function. Actually, types of function, this is categorized from the characteristics of a function. In your higher secondary first year classes, you already know about the definition of function, domain of function, codomain, range, image, preimage, etc. And here we will discuss the types of function. In the first year classes also you have learnt about some special kinds of function as like polynomial function, rational function, trigonometric functions, greatest integer functions, logarithmic functions, exponential functions, and etc. And here we are going to discuss about types of function. And I already told you that types of functions, they are categorized by the characteristics of function. So I want to tell you one thing that if you have a lack of knowledge of function, then please try to read the chapter from first year book and then watch this video, and I think you will be understand this video very smoothly. So let's get into the video with a full concentration. And before that, I want to tell you one thing that if you are interested to watch my classes, please like, share and subscribe my channel, and also press the bell icon to get the notification of my new videos. So let's get into the class with the types of function. And you see the number one. Here is the first type of the function, many one function. You may also say many to one function. So name is the introduction. Very simple. Many mean two or more elements, have one, up to one mean a single element. So many to one function mean two or more elements have same image. You see the definition. If a to b be a function, we take the function, domain is A, codomain is B. If two or more elements of the set A mean the domain set, have the same image in B, this is the codomain set B. So this definition can also be defined mathematically as like this one. This function f a to b will be a many one function if there exist two different elements. This means different, x1 not equal to x2 mean different elements. So two different elements of the domain set have same image. This fx1 is the image of x1, fx2 is the image of x2. So they are equal, but the pre-images are unequal. So two different elements have same image in the codomain set, then the function is a many one function. And it can also be established in a oval diagram. You see the oval diagram here. This is the oval diagram for a many one function. We have a function f from a to b. A is domain, b is codomain. A is holding some elements here. You see 5 elements are holding here. B is also holding some elements. You can take more than 5 elements also. So you see first element image is a single element, second element is again going to as unique element, the third, fourth and fifth, these three elements have the same image. You see the definition, two or more than two elements of A. Here more than two elements of A is connecting with a single element of the codomain set. So if you have these types of function, then the function is a many one function. So let us take one example for this these types of function. You see this example. A is equal to minus 1, 1, 2, 3 is the set A. This is the domain. B is 1, 4, 9, and the function f is from A to B defined by this definition, fx is equal to x square. Then each element of A has unique image in B. You see, if you take elements of A as the values of x, you will get each time its image is a single image. Therefore, it is obviously a function. Okay, you see this function actually, if you take x is equal to minus 1, then f of minus 1 is equal to 1 is the element this one. If you take 1, x is equal to, then fx is equal to again 1. You see, for -1 and 1, both element has the same image 1. So therefore it is a many one function. So you see here, f minus 1 is equal to 1, f1 is also 1. So the elements 1 and -1 have the same image 1 in B. Therefore f is a many one function. You see the second one, 1 1 function. Again, see the name, 1 1 function. This is also known as an injection. 1 1 function is also known as injection. So definition is written as similar to the previous one. Let f is a function from a to b. This is a function. Then f is said to be 1 1 function. 1 1 mean 1 to 1. Single element have single image. Single element has single image. So it is a 1 1 function or injection. I already told you that 1 1 function is also known as injection. So it is a 1 1 function or injection if different elements of the set A have different images of the set B. So you see the mathematical definition here. You see, so if you have two elements like this, x1 and x2, they are unequal elements of the domain set, then images are also unequal. So unequal pre-image has unequal image. So then it is called a 1 1 function, and 1 1 function is also known as injection. So let us see the oval diagram. You see here, this is the function from A to B. It is A is containing 4 elements, B is containing 5 elements. You then see this element has unique image, this element has unique image, this is also unique, this is also unique. So conformably this is representing a function. And the second thing, it is 1 1. Why this function is 1 1? Because you see the codomain set for this element, the first element, it has only one pre-image. You see, only one pre-image. Similarly for this element, only one pre-image. This element, only one pre-image. This element also have only one pre-image. So ultimately we can say that different element of the set A have different images in the set B. So if you get this types of function, each time you take an element from A, you will get a different image, different value by the definition of the function. Then the function is an injection or injective function or 1 1 function. Is that clear? Now we see say one establishment for this 1 1 function. You see, so let the set A is 1 2 3 and the set B is 3 5 7 9, and let us consider the function f is from the set A to the set B, from this set to this set. The function is f from A to B, defined by definition is this one, fx is equal to 2x plus 1. You see, if you use these elements for the value of x here, say let us take 1, then f1 will be equal to 3, mean this element. So one image is 3. If you take 2, then f2 is equal to 5. So 2 image is 5. If you take 3, then it is 7. So 3 image is 7. Therefore we see 1 image 3, 2 image 5, 3 image 7. Mean different element of the set A have different images in the set B. Therefore the function is an 1 1 function. You see here, f1 is 3, then f2 is 5, then f3 is 7. So f will be equal to 1 3 mean 1 image 3, 2 5 mean 2 image 5, 3 7 mean 3 image 7. So different element, different image. Therefore the function is an 1 1 function. Okay, now you see clearly f function from this one, f is a function from A to B such that the different elements of A have different images in B. Therefore f is a 1 1 function. You also try this as your note actually, so you should write in your copy. And see the next one, onto function. And an onto function is also known as surjection. So first of all, you take one function, say f a to b is a function. If every element in the set b mean the codomain set, for the codomain set, if there are say 5 elements, so if for all the 5 elements you think like that, so if every element in the set b has at least one pre-image in the set a, so alternatively actually the set b mean in the codomain set for all elements we have pre-image. That means there is no such element in the codomain set such that it is free from connection. Then it is an onto function. So then f is said to be an onto function. An onto function is also known as surjection. I already told you. Okay, so you see the mathematical definition. Mathematically, f a to b is an onto function if for all, you see, for all y belongs to b, b mean the codomain set, there exists x belongs to a, x mean the pre-image will be in the domain set. So for all y in b, if there exists x in a such that y is the image of x under the function f. Y is the image of x under the function f, then this function is called an onto function. You understood? Then you try to see the oval diagram. Also you see this line, very interesting line actually. In other words, you see I already told you that in the codomain set for all elements it has pre-image. Therefore there is no such element in B set which is free. That means the set B is exactly equal to the range of the function. And so alternatively we can say that if the range and the codomain of a function are equal, then we can say the function is an onto function. I think you understood this. Okay, try to see the oval diagram. You see the oval diagram. F, this is a function from a to b. You see this element image this one, this element image this one, this image this one, this image this one, and this image this one. And you see the set B, the total set, whole set B is containing these 3 elements, and the range of this set is this one. Ultimately, the codomain set and the range set are equal, and so the function is an onto function. Or alternatively, you can see here for all the elements B, for all the elements y in B, these are y actually, y in B, there exists x in A, this is x in A. For y, this is x. For y, there are 3 pre-images. So ultimately for all y belongs to B, if there exists x belongs to A such that y is equal to f of x, so then it is an onto function. So to check whether a function is onto or not, there are basically 2 ways. The number 1 way is to show whether for all the elements in the set B, whether we have pre-image in A or not. This is one of the way. And the second way is just try to find the range of the function given and find the range of the function as well. You see whether that range is equal to the codomain of the given function or not. If the range and codomains are equal, then you can say that the function is an onto function or a surjection. Is that clear? Okay, so we go to the next part. Now you see into function. So I want to recall the definitions. The first one was many one function, mean 2 or more elements have same image. Then the number 2 was onto function, one function. That was number 2 was one function. One function means different element, different images. Then number 3 we just discussed, it is codomain is equal to range, mean for all y in the set P we have pre-image in the set A, then the function is onto or surjection. Now this time we are going to discuss about into function. Into mean, with a very simple sentence you can say, if a function is not onto, this is an into function. You see the definition here, we have written that if f is a function from A to B, then if there exists at least one element in the codomain set, if you have at least one element which has no pre-image in the domain set, that means what? That means in the codomain set there is at least one free element. So if there exists one or more than one free element in the codomain set, then the function is not onto, and consequently if it is not onto, then the function is called into function. Is that clear? Okay, you see this one. The example is A is say this one, B is this set, and a function f is from the set A to B, be a function, and the definition is given this one, fx is equal to x square. This definition, I think in the many one function we also written this types of, we have also written this types of definition example. So here you see, for the element -1, by the definition, for this element -1, image is 1, because -1 square is equal to 1. For the element 1, image is also 1. For the element 2, image is 4. Now one thing you see, this element 3 is not the image of any element of the domain set. Therefore, it is not an onto function. So then we see that, we see here f -1 is 1, f1 is 1, f2 is 4. So 1, 3, 4, but here we only obtained 1 and 4. 3 is not the image of any element in the domain set. So here you see, for the element 3 there is no pre-image in the domain A, so f is an into function. So alternatively you can say that if a function is not onto, it is an onto, if a function is not onto, then it is an into function. Very simple sentence, you see. So I have written here a note. Clearly we can say that if a function is not onto, then it is into. Very simple. Okay. Now you see bisection. Bisection means this time the function at a time it is 1, 1 as well as onto. If a function is both 1, 1 and onto, then it is called a bisection or bisective function. You can say bisective function or bisection. So if a function is both 1, 1 and onto, then the function is said to be a bisection. A bisection is also known as this one, 1 to 1 correspondence. If you just write 1 to 1, then it is 1, 1 function, but 1 to 1 correspondence means it is a bisection. So you see here, this is the Abel diagram for a bisective function or bisection. See here, actually function different element different image is a 1, 1 function. As well in the set BEC, you see here there is no free element. That means the range is equal to the codomain. Therefore the function is also onto. So this function is 1, 1 as well as onto, and that is why this is a bisection. Is that clear? Okay. So see the next one. You see a important note here. F is a function from A to B. Then, when f is an 1, 1 function, and when f is an onto function, and when f is a bisection, in this case, what is the effect of 1, 1, onto, and bisection on the cardinality of a set? What is the effect of 1, 1 function, onto function, and a bisection to the cardinality? Cardinality means number of elements in a set. So what is the effect of that one? We will see here. So then you see if f is a 1-1 function, in that case you see the oval diagrams already drawn before, that in that case that the number of elements in the domain set must be either equal or less the number of element in the set B. If a function is 1-1, then in the set A and B either there are equal number of elements, or in A the number of elements less than the set B. If a function is 1-1, then this condition will be satisfied. Then the second one, if f is an onto function, if f is an onto function, then you see the oval diagrams you already drawn, that in the set A there must some more elements than the set B, or there are equal number of elements in A and B. This is the condition. If a function is onto, then it will be a consequence of that one. Now you see the third one, if f is a bisection, we just discussed bisection. Bisection means this time number of elements in A and number of elements in B, that is number of elements in domain and number of elements in codomain must be equal. Now you see identity function. About identity function, I think you already studied in the first year, though this symbolic notation was not given in first year. Identity function means it is a function with domain and codomain are equal. First condition is that one. And secondly, image and pre-image are also equal. If in a function image and pre-image are equal, as well domain, codomain and range all are equal, then the function is called an identity function. And you see, actually identity function, I mean this can be considered as y. So y equal to x. It is a straight line actually. Identity function is a straight line passing through the origin and bisecting the first and third quadrant. So that will be the graph of an identity function. So you see that identity function is denoted by IA. This A is written as suffix of I. What is A here? A is nothing but the domain of the function. The domain is A, that is if the identity function is defining on the set A, then you are to write IA. If the identity function is defining on the set serial number, then you are to write IR, as like that. Okay, so IA of x is equal to x, mean image of x is equal to x. So in identity function, the codomain, domain, image and pre-image are equal. Here you see for all x belongs to A. So obviously this identity function is a 1-1 function, is an onto function as well. We can say that since it is 1-1 as well as onto, therefore it is a bisection. It's called an identity function. Here you see it is clear that an identity function is both 1-1 and onto. That means it is a bisection with the domain and range as A. You see this one, identity function A to A. IA is the symbolic notation of identity function. Image and pre-image, these two are always equal, always equal. Now you see equal function. Equal function means two functions f and g are said to be equal. These two functions are equal. First condition is that their domain must be equal. You see here it's said to be equal if they have the same domain. And the second condition is fx is equal to gx, mean the ranges are also equal. Then the function is called then the two functions are called equal functions. You see even and odd function. These two functions actually we discussed in the first year classes. even and odd function. F a to b, this function is said to be an even function. This function is said to be an even function if it satisfies this relation. F minus x is equal to fx. And if f minus x is equal to minus fx, then it is called an odd function. So even and odd, in the first year class you already know that the graph of an even function, this is symmetrical about the y-axis, and for odd function it is symmetrical about the origin. By observing a graph of a function, you can obviously say whether that function is an even function or is an odd function, just observing the graph. If you see the y-axis is acting like a mirror for the left part or for the right part of the graph of the function, then you can say that this is an even function. And mathematically, after replacing x by minus x in the definition of a function, if you get the function itself, that is no change in the definition of function after replacing x by x, then you say that the function is an even function. And in case of odd function, you replace x by minus x, and after replacing that, if you see that there is a minus sign common in front of the definition of the function given, then it is an odd function. Everything will be same, just there will be minus in front of the function, definition of the function. You see two examples here. Fx is equal to cos x. If you see, replace say x is minus x, x by minus x, then f minus x will be cos minus x. And we know from trigonometry that cos minus x is obviously cos x. Therefore, f minus x and f x, these two are equal. Therefore, we can say that the function fx is equal to cos x. This is an even function. Similarly, here also gx is equal to x square. You see this? After replacing x by minus x whole square is again x square, is not it? So x square is again gx. So we see here that gx and g minus x both are equal, and therefore this function is also an even function. And you see these two examples, these two. Hx is equal to sin x. Now replace x by minus x. In that case, sin minus x. And from trigonometry, sin minus x is equal to minus sin x. That means minus hx. So after giving x is equal to minus x, we see that minus will come in front of the function, and therefore it is an odd function. And here you see Rx is equal to x cube. Again replace x by minus x, then minus x whole cube, it is obviously equal to minus x cube, that is minus Rx. So Rx and R of minus x, these two are equal, and that is why Rx is equal to x cube. This function is also an odd function. Clear? And I also draw two graphs for even and odd function. You see the graphs, and it will be very easy to understand whether a function is even or not by just observing the graph of the function. You see the graph. First we see that fx is equal to x square. This is an even function, you know that one. This is an even function. And you see this is our y-axis, and this is the graph of y is equal to fx, or y equal to fx is equal to x square. And you see, if you think like that, this y-axis as mirror, you think about that, and you have say drawn this part of the graph. If you place this left part of the graph in front of a mirror, that is y-axis, it will complete this total graph. So therefore y-axis is acting like a mirror for the graph of fx is equal to x square. and therefore this function is an even function. I think you understood this one. Okay, so you see the next one, forward function. Now you see this graph, fx is equal to x cube. We already told you that this function is an odd function, and this will be the graph of the function fx is equal to x cube. Okay, you see here from the origin, this part and this part. This part is the mirror image of this part about the origin. Mean the graph of x cube is symmetrical about the origin, and that is why this function is an odd function. Is that clear? So an even function is symmetrical about the y-axis, and an odd function is symmetrical about the origin. Two important things. Just by observing any graph of a function, you can say whether that function is even or odd. Is that clear? So I want to finish this class here. All these types of functions are discussed. These are the types of functions. So what are the types? Many one function, one function, many one onto function, into function, bisection, even function, odd function, equal functions, etc. So you try to understand this class. Yeah, I think you already have written the notes in your copy. Read the notes, and if you have any confusion with the class, then you can ask me over phone, and I think you have the number, you have my number with you. If you have not the number with you, you may call me in the number 99547888475. This is my number. The number also contains WhatsApp, so you can ask me directly over phone. Okay, so in the next subsequent classes, in the next subsequent videos, we will discuss about the question part of this chapter. We will discuss various types of questions related to the chapter function, related to one function, related to onto function, how to check a function is one, how to check a function is onto. We will discuss these types of questions in the subsequent videos, and I will give that video, I will upload that video within short time. So be connected with me and try to understand the classes. Okay, so I finished this class today. Thank you very much.